Good morning and welcome to my YouTube channel, Pearson and Excel International Maths. And today we continue to explain Pure Mathematics 2. And we are moving on with Chapter 1. And we're going to look at something that is quite important, the Factor Theorem. And now that we have known how to divide functions, we need to get shortcuts of how to deal with this division of the functions, and even how to know whether a divisor is a factor of a function. And of course, we need to understand that the factor theorem states that if fx is a polynomial, if fx is a polynomial, then the following facts will follow. 1. If fp is equals to 0, we talk of then x minus p is a factor. We are going to elaborate this further. If this one is a divisor, x minus p, then if this is true, then fp is equals to 0. We can even put it in a different way. If x minus p is a factor then of fx, then fp itself is equals to 0. It's just like what you've said. And you remember, and in a different way, we're saying that if fb over a is 0, then ax minus b is a factor. We're going to explain all this. Is a factor of fx. Even here, a factor of fx. And if ax minus b is a factor of fx, then fb over a is 0. It's the same thing said from reverse. And we know that a factor is a function or is a divisor that will divide a function without a remainder. And if we divide without a remainder, then that is a factor. That is why we're talking about fp is being equals to 0. And you can use the factor theorem to quickly factorize functions, cubic, and all what we have in a very simple way. And it is important to note that you need to understand the bold on page 7. Substitute values into the functions until you find a value p such that fp is equals to 0. Substitute values into the function until you find a value p such that gp is equals to 0. Okay, we're going to do this in the following example, but this is what I'm talking about. So you can use the factor theorem to quickly factorize a cubic function gx, and there are 4 steps there. Substitute values into the function until you find a value p such that gp is 0. Divide the function by x minus p. Write gp is equals to x minus p multiplied by the quotient that is realized, ax squared plus bx plus c. And of course, 4, factorize the quadratic factor if possible to write gx as a product of 3 linear factors. All those steps are going to be explained in example 5 through example 6. And in example 5, let's just talk about example 5. Show that, because it ought to show that x minus 2 is a factor of x cubed plus x squared minus 4x minus 4 by 1 algebraic division, and 2 the factor theorem. And let's just start with algebraic division. We are told that if this is a factor of this, then even if we divided using the long method, the remainder will be 0. Let's just talk about step number 1 here. So x cubed plus x squared minus 4x minus 4 divided by x minus 2. This is x squared, multiply out x cubed minus 2x squared. You subtract this, you get 3x squared. You drop this minus 4x, and then plus 3x, multiply out 3x squared, minus 6x, 2x, subtract minus 4, drop this, you drop this there, 2x divided by x plus 2x minus 4, and the remainder is 0. Now that the remainder is 0, then x minus 2 is a factor of x cubed plus x squared minus 4x minus 4. Now that you see, now that the remainder is 0. Let's go to second approach. We have verified there is a factor. We told that fx is equals to x cubed plus x squared minus 4x minus 4. And the divisor is x minus 2. This one is already in the form of x minus p. So if we talk about, if this is a factor, then fp is going to be 0. So what is our p? Our p is 2. So f2 is equals to 2 cubed. You just substitute this 2 in the general equation, 2 cubed plus 2 squared minus 4, 2 minus 4. So this is 8 plus 4 minus 8 minus 4, which is basically 0. And that is true because f2 is equals to 0. Then it proves then x minus 2 is a divisor, is a factor. Is a factor of x cubed plus x squared minus 4x minus 4. So both ways have verified that x minus 2 is a factor. All right.